So in this section, let's do the Mann-Whitney U test. Now, that's probably the most common non-parametric test that you're going to find out there in the literature. Quite confusing though, for the pure reason that there are so many names for it. And that is really what happens when you attach people's names to tests. So you're going to see Mann-Whitney U, most commonly. You're probably also going to see Mann-Whitney Wilcoxon. And that makes it difficult because Wilcoxon on its own has a different type of test. You're also going to see Wilcoxon Mann-Whitney. You're going to see Wilcoxon rank sum test. At least that last name helps us out because we are going to use the rank sums method when this is done. So look at an example. Read the article by the study by Craig and colleagues, and they looked at the risk factors for overweight and overfatness, two different things, in rural South African children, and that was published in the Journal of Public Health in 2015. Now, if you read in the abstract method section there, you'll see they say they use the Mann-Whitney U test. Now, look at table 1 specifically, so I'm halfway down table 1. You'll see that they compare between the non-obese and obese and the non-overfat and overfat. They just compare the median distances to the schools. So for each group, there's two little groups there, two little groups there, two separate analysis, two groups in each, and they just look at comparing the medians to the school, distance to school for those children that obviously be between their houses and their schools. Now, what they are doing here and what you use the Mann-Whitney U for is exactly the same as you would a normal t-test or student's t-test. We are comparing two groups with each other, values in two groups. Now, those values that we're looking at, they've got to be either numerical or at least, if they are categorical, they've got to be ordinal categorical. In this instance, they were using kilometers, that's the distance to the schools. So in case it is numerical then, as in this case, they are using the medians, they are using non-parametric tests because they found that those distances to school did not follow a normal distribution pattern. So we are going to go for a non-parametric test. Now, remember when we had the AB, when we looked at rank sums, that's exactly what is happening in the Mann-Whitney U test. So you could rank those distances to school for each group, and they're going to fall in some rank, and you can follow either of the two methods which we discussed, either those tennis playing matches or simply just summing up the rank values for each of those values. Again, we're talking about the distribution of the ranks and not the actual values, because those actual values do not come from a normal distribution. Now, the null hypothesis for this Mann-Whitney U test would just suggest that there is no difference in the medians between the two groups, and the alternative hypothesis, if it's two-tailed, will just say that there is a difference, and the one-sided test with one group actually having a median more or less than the other group, and it's purely determined by the actual matter at hand, what you are researching, and it should make logical sense why a two-tailed test and a one-tailed test was used. And as with all hypothesis testing, you really have to make that judgment call between a one-tailed and a two-tailed test as far as the alternate hypothesis is concerned before any data acquisition or data analysis is concerned. Otherwise, it is purely unethical. Now, whichever of the two rank sum methods that is used, you then calculate with the computer or just look it up in the table. You'll get the statistic which you can convert to a p-value. So that is the Mann-Whitney U test. It's a non-parametric test comparing the medians of two groups. Now, in the next section, the last section in this lesson, we're just going to discuss a few other of the more commonly used non-parametric tests.